hello everyone. Hello. Hello.
Yeah.
All right. Hello everyone. We are the first person remotely piloted car, and our advisor is Dr. Martin.
I'm Andrew Martin. I'm a rising senior at Metuchen High School.
My name is Ben Yu, and I'm a rising senior at East Brunswick High School.
My name is Leo Shu, and I'm a rising senior at Pinger.
And my name is Aditya Sarakul, and I'm a rising senior at JP Stevens High School.
All right, so our goal of this project is we want to create a remotely piloted car that can be controlled from anywhere. And we want to have a camera view, a first-person camera view of the robot, so that the user is able to control the robot with its surroundings in mind. And we want to be able to maneuver this car in any direction that we want, which is where the mechanism wheels come in handy, which allows us to move in any direction and rotate without moving forward. In the following slides, I'll show you the steps and parts that we use to make this happen.
So at the beginning of the summer, we got a kit for the entire car, and you can see the kit right here. It has the mechanism wheels, motors, an Arduino, some drivers, and a basic chassis that we could use. And then over the summer, we used a series of upgrades. So the first one was switching over from an Arduino to Raspberry Pi to make the car basically its own computer. To do that, we have to replace some of the drivers and use female-to-female jumper cables, which we had to create ourselves. And then after that, we added in a camera, which would have a first-person view, and that is the orange camera that you can see right here. And then we also had that talk with the Raspberry Pi to talk to our computer. Then afterwards, we decided to add a separate metal chassis, which was much stronger and much bigger. But to do that, we had to 3D print a mounting plate, and we can see that right here, and that's the final version of our robot that we're using currently.
So in order to get full wireless remote control of a robot over the internet, we had to use zero tier. So zero tier is a VPN virtual LAN network, and it allows users from two different locations to connect over the internet as if they were on the same network. So each device has its own zero tier specific IP address, and you can connect using zero tier on a network, each zero tier device through that network. So we use zero tier on a robot for connecting the robot and the user protocol, user device both to zero tier. And then on that zero tier connection, the user and the robot can speak to each other as if they were on the same network, allowing us to use virtual LAN connection from anywhere in the world, basically, as long as you have internet connection. So it allows for a complete remote control of the robot, and the user has virtually like unlimited access to the robot. I think that something can enter it.
Okay, so being that our project is a first-person view remotely piloted car, we needed a camera, and we needed something that could process the raw camera data. So we used OpenCV, which is a programming library that you might have heard, and it's used for real-time computer vision and machine learning. So for our uses, we basically used the Raspberry Pi to basically compile the raw camera data that we got from the orange camera that you could see earlier. And we would compress that raw camera data into JPEGs, and then convert those JPEGs into byte arrays, and then send those bytes through a socket, which I'll explain later. And we use bytes because sockets take bytes as the data type. And then we would receive those bytes on the user's end, so like a laptop, and we would decode them back into JPEGs and display the JPEGs as a video. And you can see over here, that's an example of what you could see if you use OpenCV to display video. Okay, and I mentioned earlier sockets. So network sockets are used to communicate between multiple computers over the internet. Sockets have two ends, a client end and a server end, and the client sends the data to the server end, which receives that. And there are many different types of sockets. We experimented with UDP and TCP. We first tried TCP and we found that it was pretty good. It was definitely slower though than UDP due to TCP being more secure because it has more checks to ensure that packets are delivered. But for our uses, we needed UDP because UDP is a lot more fast. It's more efficient due to the less secure checks. And for our uses, we needed as minimal latency as possible. So we started with UDP. We used sockets twice in our project. We used the socket, we used one socket for camera data. So that was where the robot was a client. It had the camera and it would send that camera data to the user's computer, which was the server receiving it. And we also used another socket for movement control. So in this case, the user's computer is the client because it would be sending controls to move the robot, and the robot would receive it as a server.
All right, so for our final process of putting this all together, we first use the 0 tier to connect the robot and the user's computer. And then we use sockets so that we can communicate between the user's computer and the robot. And we'll use sockets to send instructions from the computer to the robot, and then the robot can process that into physical motion. And at the same time, we'll have the robot send back UDP packets, or we'll send back the footage, the camera footage, in the form of UDP packets. As Ben said, we use the OpenCV to transfer the footage into a byte array, which we can then send over UDP packets to the computer side, which can be viewed by the user. And then since the user has the camera footage, we want to be able to control the robot in the simplest way possible. So we coded the robot to use hotkeys to control the robot. We have controls shown on the slide. We just chose simple keys so that it'd be easier for the user to control. And using this, we can control a robot through whatever obstacles we might have. And we'll show a video of this on the next slide.
Okay, so in this video, I'm testing the robot. I'm controlling it from my house, and I'm controlling it in Andrew's house. And you can see that over here, I'm typing in the Pi's 0 tier specific IP address. And I have 2 windows open so I can run 2 codes. And then after I typed it, I gave myself a 20-second buffer so then I could type in my own computer's 0 tier specific IP address. And then after I typed it in on both sides, you could see the troubleshoot code, and now we're receiving camera data. And this is in Andrew's house, and I'm seeing on my computer in my house. And then that's Andrew. And then you can see that the movement code has kicked in. It's a little bit choppy over here because this was filmed in Andrew's, the camera was in Andrew's 3rd floor, so the Wi-Fi signal wasn't as strong. But we also tried it in Adi's house yesterday, and we had pretty good Wi-Fi there, so we were able to control it pretty well actually with really clear video feed. And you can see over here I'm navigating through the little tunnel. I'll cut this video short there.
So conclusions and future directions for our project. So we were able to successfully run the robot remotely and pilot it remotely, which was our end goal for the project. So we can say that we were successful in completing our main goal for this project. So we were able to get to low latency with little to no hitches within the setup, except for if the Wi-Fi signal became weakened, then we would start to see a higher latency in the camera and control movement. But that could be attributed to more packet loss because of a weaker Wi-Fi signal. And for future directions for our project, we want to get an Intel RealSense camera to work. But what that camera does, it's a 3D camera. It creates a point cloud, and that camera can be used to do future self-driving capabilities, as well as any like driver assistant capabilities, such as stopping if it gets too close to a wall. So, any questions?
So you said later it will be self-driving. So now it's just a remote control by
Yes.
your side.
So right now we still need a user to control the robot remotely, but hopefully in the future we can get it to where it can be either fully self-driving or partially autonomous.
And so the remote control, you can control the vehicle in any direction.
Yes, we have full 360-degree movement in the X and Z directions. We don't have a Y direction movement because it's a car. So, yeah, so in the X and Z directions, we have full 360 movement.
And then what if you control the vehicle but it hits something? So what's next?
That's why we're trying to do the real sense camera. It'll allow us to detect how close objects are and will give a warning to the user or maybe automatically stop the car since it's getting this thing too close.
So you mean that sensor part is the future work?
Yeah, that's part of the future work that we're trying to do.
So so in your project, your contribution is to make this you change it from previous thing not to the Raspberry Pi and that make it work.
Yeah, we transferred from an Arduino to a Raspberry Pi and that allowed us to run more advanced code on the laptop. Any more questions? Okay, thank you.